Hey there, I'm Joe Carter. If you've ever popped the hood and thought, where do I even start? You're in good company. Around here, we take the mystery out of car repair, one fix at a time. Whether you're a beginner or just looking to sharpen your skills, there's something here for you. Don't forget to like the video and subscribe if you're into learning without the headaches. All right, that's enough from me. Let's get into it.
Support journals serve to support the crankshaft in the so-called beds. They hold the bearings that do not shift during operation and provide rotation. As the main journals are more heavily loaded, their diameter is larger than that of the connecting rod journals. If the crankshaft is designed so that there are bearing journals on either side of each connecting rod, it is called a full support crankshaft, otherwise it is called a partial support crankshaft. The most common crankshafts in modern automobile engines are full support crankshafts. The crankshafts are connected by cheeks, counterweights, which are extensions of the jaws to the opposite side of the crankshaft, balance the centrifugal forces that arise during rotation. There are oil channels inside the crankshaft, which lubricate the connecting rod journals. What materials and how the crankshaft is made of the material and production technology depend on the class and purpose of the vehicle. For standard production vehicles, the crankshaft is cast from cast iron. This minimizes production costs. The crankshaft of more powerful and sporty cars is forged and made of steel. Compared to cast iron, it has improved characteristics in such parameters as dimensions, weight and strength. The most expensive option, used in luxury models, is a crankshaft forged from a single piece of steel. The jaw-to-jaw transition point is the most stressed, as the maximum stresses are concentrated here. In order to relieve stresses, the joint is made with a semicircular transition groove. As a rule, the flanges are made double with an intermediate technological belt. This design solution allows the maximum active area of the journals, i.e., the surface under the liners, to be retained. Just because of the high loads in the joints, the crankshaft of composite design, in which the individual parts are connected with each other by fasteners, has not found wide application. What a crankshaft is needed for by means of the crank mechanism of the engine, the reciprocating motion of the engine cylinder pistons, is converted into rotary motion and transmitted through the transmission to the wheels of the vehicle. The crankshaft is just what is needed to accomplish this transformation. During operation, each of the pistons of a four-stroke engine is constantly in one of the strokes: intake, compression, stroke, exhaust. During the stroke phase, the piston pushes the connecting rod, which in turn moves the crankshaft. This is how rotation is realized. Next in the order of the engine cylinders, the piston at this time compresses the combustible mixture and after its ignition pushes its connecting rod, resulting in continuous rotation of the crankshaft. Flywheel. The flywheel, a solid cast iron disc with a pressed-on gear ring, see photo, is bolted to the rear end of the crankshaft. When viewed from the belt chain side of the timing chain, to prevent the flywheel from shifting and balance, there are centering pins or special bolts located asymmetrically. To prevent oil leakage, an additional seal, oil seal, is installed on the flywheel flange. The flywheel accumulates the energy necessary to maintain uniform rotation between ignitions of the combustible mixture in the cylinders, and takes the pistons out of the dead points, extreme upper and lower positions of the piston in the cylinder. The flywheel gear is connected to the starter gear. When starting the engine, the flywheel is rotated by the starter, giving the shaft initial rotation. Finally, it is through the flywheel that rotational motion is transmitted to the transmission units and assemblies. In conclusion, the crankshaft plays a vital role in the operation of an internal combustion engine. Its intricate design and robust construction allow it to convert the linear motion of the pistons into rotational motion, ultimately powering the vehicle. Understanding its components and functions not only highlights the engineering marvel behind modern engines but also emphasizes the importance of maintenance for optimal performance. As we continue to explore advancements in automotive technology, the crankshaft remains a fundamental element in the evolution of engine design. Thank you for watching, and we hope you gained valuable insights into this essential engine component.